We know one more property, integral of a to b f of x dx is also equal to integral a to b f of t dt. Integral a to b f of x dx is also equal to integral a to b f of a plus b minus x. So x is replaced by a plus b minus x. So if f of x is an odd, then that is 2 times 0 to a f of x dx. If f of x is an even function, then that is equal to 0. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in this session I am going to discuss regarding very important concept for 6 marks, that is properties of integrals. So, properties of integrals and the problem based on the properties of integrals for 6 marks. Straight away I will go to property 3. Now, what is this? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x, that is sum of lower limit plus upper limit minus x. So, integral a to b f of x dx is also equal to integral a to b f of a plus b minus x. So, x is replaced by a plus b minus x. Now, let us take RHS. Straight away take RHS, integral a to b f of a plus b minus x. Now, what is to prove? To prove that integral a to b f of a plus b minus x is also equal to integral a to b f of x dx. Now, let us take the substitution. Let t is equal to a plus b minus x. Put t is equal to a plus b minus x. Differentiate it. dt by dx is equal to differentiation of a constant, b constant 0, differentiation of x is minus 1, dt is equal to minus dx, or minus dt can also be written as plus dx. Now, as you know, whenever the substitutions are taken, the value of limit also changes in definite integrals. Now, what is the substitution we have taken? T is equal to a plus b. When x is equal to, the lower limit is a. When x is equal to a, what happens to this t? T is equal to a plus b minus x is equal to a, minus a plus a gets cancelled, this reduces to b. So, lower limit a converts to b. And the upper limit, when x is equal to b, what happens? T, here substitute here, t is equal to a plus b minus b. Minus b plus b gets cancelled, this is equal to a. So, a to b will reduce us to b to a. So, whenever substitutions are taken, the value of limit also changes. Now, this is equal to, this is dx. Now, integral, the given integral becomes a to b. A to b is converted into b to a, f of, what is the substitution we have taken? A plus b minus x is equal to t, f of t. And what is dx? Dx is equal to minus dt. Now, this can also be written as minus integral b to a, f of t and dt. Just take negative sign out. So, just listen to me here. Let us take RHS. What is RHS? Integral a to b f of a plus b minus x. Put t is equal to a plus b minus x. Differentiate it. dt is equal to minus dx or minus dt is equal to dx. Whenever the substitutions are taken, the value of limit changes. When x is equal to a plus b minus a plus a gets cancelled, we will get b. When x is equal to b, t is equal to a plus b minus b plus b gets cancelled, we will get a. So, the given integral becomes a to b is converted into b to a, f of a plus b minus x is t, and dx is equal to minus dt. We can take minus out. Now, according to the property, we know that since we know the property integral a to b f of x dx is also equal to integral b to a f of x dx along with negative sign. If you interchange the integral will take the negative sign. So, therefore, this RHS integral minus b to a f of t dt can also be written as, according to this property, integral b to a can also be written as a to b f of t dt along with positive sign. Since we know one more property, integral a to b f of x dx is also equal to integral a to b f of t dt. We know one more property, integral of a to b f of x dx is also equal to integral a to b f of t dt. So, this can also be written as integral a to b f of x dx f of x into dx. This is nothing but the required LHS. See, what is LHS? Integral a to b f of x dx. So, what is the conclusion? Therefore, we can say that integral a to b f of x dx is also equal to integral a to b f of a plus b minus x into dx. This is very important property. You may expect this for your 6 marks along with one problem, part E. Okay, I'll take one example for this. So this is how we are going to evaluate. Hope you followed. Okay, now let us come to the next property, a similar type property. Okay, property number 4, 0 to a f of x dx is also equal to 0 to a f of a minus x. So same type problem, same property, a minus x, x is replaced by upper limit minus x, that is a plus x, a plus 0 minus x, that is a minus x. Now here let us write as usual, we can go to the right hand side. Let us take RHS integral 0 to a f of a minus x dx. Now what is to prove? To prove that integral 0 to a f of x dx is also equal to 0 to a f of a minus x into dx. Now let us take RHS integral 0 to a f of a minus x. Now let us take the substitution. Put same as usual, t is equal to a minus x. Differentiate it. Dt by dx is equal to differentiation of a is 0 and x is minus 1. So dt is equal to minus dx or minus dt is equal to dx. Now whenever the substitutions are taken, you know the value of limit changes. What is the lower limit we have? When x is equal to 0, this t become a minus 0, that is equal to a. Lower limit become a. When x is a, upper limit, when x is equal to a, what is t? T is equal to a minus a, this becomes 0. So lower limit becomes a and upper limit becomes 0. So therefore this integral 0 to a can be written as a to 0 f of what is a minus x t and what is dx minus dt. So you can take negative sign out, minus out, a to 0 f of t into dt. Okay, so see same type as that of the previous problem. So put t is equal to a minus x, differentiate it, you will get dx is equal to minus dt, and the lower limit when x is equal to 0, t is equal to a, and when x is equal to a, t is equal to 0. So the given integral a to 0 f of t minus dt, we can take minus out, a to 0 f of t dt. So this can also be written as, that is integral minus a to 0 f of t dt. As we know, if you interchange the integral, a to 0 can also be written as 0 to a into f of t dt. This will become positive. Further, according to the property, we know integral a to b f of x dx is also equal to integral a to b f of t dt. Okay, this can also be written as 0 to a f of x dx. This is what the required LHS. That's it. Okay, that's regarding the property. Okay, hope you followed. So very simple concept. There is one more example for this. I will take the example after explaining the properties. Now let us come to the next property, and this is very important property. To prove that integral 0 to 2a f of x dx is also equal to 2 times 0 to a f of x dx if f of 2a minus x is equal to f of x, and 0 if f of 2a minus x is f of x. That means, so if f of x is an even function, then it is 2 times integral 0 to a f of x dx. If f of x is an odd function, then this integral is equal to 0. Now what is to prove? To prove that integral 0 to 2a f of x dx is also equal to 2 times integral 0 to a f of x dx. If f of 2a minus x is equal to f of x, means that's an even function. 0 if f of x is an odd function, that is f of 2a minus x is equal to minus f of x. Okay, proof. Let us come to the proof. Now we know that according to the property, we know integral 0 to 2a f of x dx is also equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. This is equation number 1. This is from previous property. We note integral 0 to 2a f of x dx is also equal to 0 to a into f of x dx plus 0 to a into f of 2a minus x. Now let us come to case 1. Case 1. What is case 1? If f of x is equal to f of 2a minus x. So if f of 2a minus x is equal to f of x, so then this equation becomes, this reduces to integral 0 to a f of x dx as it is. Equation 1 becomes integral 0 to a, this 0 to a, f of 2a minus x. F of 2a minus x can be written as f of x into dx. So, what is this equal to? 0 to 2a f of x dx plus 0 to 2a f of x dx is nothing but 2 times 0 to a f of x dx. That is your first part. So, that means, therefore, integral 0 to 2a f of x dx, f of x dx is equal to 2 times 0 to a f of x dx if f of x is equal to 2a minus x. That is case number 1. Now, let us come to case 2. Case 2. In case 2, if, what is the case 2? If f of 2a minus x, if f of 2a minus x is equal to minus f of x, then this equation 1 becomes, equation 1 can be written as integral 0 to 2a f of x dx is equal to 0 to a f of x dx plus integral 0 to a f of 2a minus x can be written as, this can be written as, this is 0 to a f of x dx as it is. Okay. Now, then this 0 to a f of 2a minus x, this is 0 to a f of 2a minus x is equal to minus f of x. This becomes minus f of x into dx. Minus f of x plus f of x gets cancelled, 0. That's it. So, therefore, what do you say? Integral 0 to 2a f of x dx is equal to 0 if f of 2a minus x is equal to minus f of x. That's it. Very simple property. So, if f of x is an odd, then that is 2 times 0 to a f of x dx. If f of x is an even function, then that is equal to 0. That's it. Very simple concept, very important. See, the important thing is from previous property, we know that integral 0 to 2a f of x dx is also equal to 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now, let us take case number 1. What is given? If f of 2a minus x is equal to f of x, substitute here 0 to a f of x dx, this becomes f of x, 0 to a f of x dx, 0 to 2a f of x is 2 times 0 to a f of x dx. Now, case number 2, if f of 2a minus x is equal to minus f of x, substitute here, minus f of x plus f of x gets cancelled, 0. So, therefore, you can say that integral 0 to 2a f of x dx is equal to 2 times 0 to a f of x dx is f of x is f of 2a minus x, 0 if f of 2a minus x is equal to minus f of x. That's it. So, here the thing is, this is very important property, you should have to be remember. Now, the very important step is, this is from property number, from previous property, from previous properties. So, you should keep it in mind, integral 0 to 2 f of x dx is equal to 0 to a f of x dx plus 0 to a f of 2a minus x. Now, let us come to the next problem. Same type problem, property number 7, minus a to a f of x dx is equal to 2 times 0 to a f of x dx is f of x is an even function. That is, even function means f of minus x is equal to f of x, and f is an odd function if f of minus x is equal to minus f of x. Same type problem. Okay, this is also very, very important for 6 marks. Now, let us take LHS minus a to a f of x dx. Now, according to property number 2, this can also be written as integral minus a to 0 f of x dx plus 0 to a f of x dx. Let us represent this as equation number 1. Split the integral. So, according to previous property, second property, minus a to a f of x dx can also be written as minus a to 0 f of x dx plus again 0 to a f of x dx. Now, here put t is equal to minus x. Put t is equal to minus x. This is same as it is. Don't change this. So, if you differentiate this, dt is equal to minus dx or minus dt is equal to dx. Now, whenever the substitutions are taken, the value of limit changes. When x is equal to minus a, this t becomes minus of minus a is equal to plus a. When x is equal to 0, this t becomes 0, right? This integral becomes, let me explain, minus a to a, minus a, what is lower limit? Minus a is converted into plus a to 0, f of, what is x? X is equal to minus t, and what is dx? Dx is equal to minus dt, plus the second part is same as it is, 0 to a f of x dx. This is equation number 1. Now, I will take this, I will go to the next page. Therefore, this becomes integral a to 0 f of minus t, and just take this minus dt minus out minus of dt plus integral 0 to a f of x dx as it is. If you interchange the integral a to 0 can also be written as 0 to a, this minus becomes plus f of minus t into dt plus integral, this is same, 0 to a f of x dx. Now according to property, this can also be written as integral 0 to a f of, if t is replaced by x, then this becomes f of minus x into dx plus 0 to a f of x dx. Now this is minus a to a f of x dx. Left hand side what we have, minus a to a f of x dx is converted into this. Now let us represent this as equation number 2. Now there are two cases arises. When case number 1, case 1, when, what is the condition given? F of minus x. When f of minus x is equal to plus f of x. Case number 1. Case 1, if f of minus x is equal to plus f of x, substitute here, this equation 2 becomes integral 0 to a f of minus x is nothing but plus f of x dx plus second part is same, 0 to a f of x dx. This is equal to 0 to a f of x dx plus 0 to a f of x is nothing but 2 times 0 to a f of x dx. That is the first answer. See here, very simple. Case number 1, f of minus x is equal to f of x. So that is an equation 2 becomes 0 to a f of minus x is replaced by f of x dx, 0 to a f of x as it is, 0 to a f of x dx plus 0 to a f of x dx is 2 times 0 to a f of x dx. That is your first part. Now case number 2, let us write case number 2. I'll write here case 2. In case 2, what is the case 2? If f of minus x is equal to minus f of x, that is for an odd function. So then this equation 2 becomes minus a to a f of x dx can be written as, here this f of minus x is nothing but minus f of x, this is minus f of x. So 0 to a minus f of x dx plus 0 to a f of x dx. What happens? These two gets cancelled, this is equal to 0. So therefore, what do you say? Therefore, we can say that minus a to a f of x dx is equal to 2 times 0 to 2a f of x dx is f of x is an even function, 0 if f of x is an odd function. Very simple concept. Just split this and consider f of s substitution, take t is equal to minus x. Whenever the substitutions are taken, the value of limit changes. This equation will reduce to 0 to a f of minus t dt, 0 to a f of x dx. So again using property, so if x is t is replaced by x, then it will becomes minus x dx, 0 to a f of minus x dx plus 0 to a f of x dx. Now case number 1, if f of minus x is equal to plus f of x means f of x plus f of x is 2 times f of x. If f of minus x is equal to minus f of x, case number 2, even function and odd function. For even it is 2, for odd it is 0. This becomes minus f of x. So minus of f of x dx plus 0 to f of x gets cancelled. That's equal to 0. That's it, right? So therefore, the final answer is 2 times 0 to a f of x if the function is an even function, 0 if the function is an odd function. Hope you follow. Very important property indeed. Now let's come to the problem based on this. Let me take few problems based on this. So in the examination for 6 months, they will ask one property. Along with consult to that property, they will give one small example. Now, according to this property, minus a to a f of x dx. So using that property, evaluate minus 1 to 1 sine to the power of 5x cos to the power of 4x. Now here let us consider what is the function f of x is sine to the power of 5x into cos to the power of 4x. Suppose if x is replaced by minus x, sine to the power of 5 times minus x into cos to the power of 4 times minus x. So this is minus sine 5 and cos to the power of minus 4 is equal to cos of 4 plus times. So this what you will get, this is equal to minus f of x. That means if f of minus x is equal to minus f of x means f of x is an odd function. If it is an odd function means according to the property, If it is odd means then it is equal to 0. So this is equal to odd function. So therefore according to property the value of this is equal to 0. So therefore this is equal to 0. Integral minus 1 to 1 sine to the power of 5x cos to the power of 4x dx is equal to 0. That's it. Very simple. Now let us come to the next problem. So this is very important type problem. Now integral 0 to pi by 2 sine to the power of 4x divided by sine raised to 4x plus cos to the power of 4x. Now let us consider, let I is equal to integral 0 to pi by 2 sine to the power of 4x divided by sine to the power of 4x plus cos to the power of 4 times x into dx. Let us represent this as equation number 1. Change or replace x to pi by 2 minus x according to the first property. Now pi by 2 minus x. So if x is replaced by pi by 2 minus x, this is 0 to pi by 2 sine to the power of 4 times pi by 2 minus x divided by sine to the power of 4 times pi by 2 minus x plus cos to the power of 4 pi by 2 minus x into dx. So therefore this equation becomes I is equal to integral 0 to pi by 2. We know that sine 90 minus theta. Sine 90 minus theta is equal to cos theta. What is sine 90 minus theta? Sine 90 minus theta is cos theta, and again cos 90 minus theta is also equal to sine theta. According to this property, sine pi by 2 minus x is cos to the power of 4x divided by sine converts to cos to the power of 4x plus cos 90 minus theta is equal to sine to the power of 4x dx. Let us represent this as equation number 2. Now see equation 1 and 2, sine power 4x, there it is cos to the power of 4x, sine to the power of 4, cos to the power of 4, cos to the power of 4 plus. So just adding 1 and 2, if you add equations 1 and 2, on the left hand side what we have, I plus I is equal to integral 0 to pi by 2. First equation, sine to the power of 4 x divided by sine to the power of 4x plus cos to the power of 4x dx plus equation number 2 is same, 0 to pi by 2 cos to the power of 4 cos to the power of 4x divided by, here it is cos to the power of 4x plus sine to the power of 4 times x into dx. Now this I plus I is 2I is equal to, you can take 0 to pi by 2 and take the LCM. What is the LCM? Sine to the power of 4x plus cos to the power of 4x. So this can also be written as sine to the power of 4x plus cos to the power of 4x into dx. So this is equal to 0 to pi by 2. This 2 gets cancelled, integration of dx. So 2I is equal to integration of dx is x between the limit 0 to pi by 2. Apply the limit pi by 2 minus 0 is equal to pi by 2. 2I is equal to pi by 2. Therefore, I is equal to pi by 2 by 2 is pi by 4. So the answer you are going to get is pi by 4. In majority of this type of problems, so you will get the answer as pi by 2 whenever the limit is from 0 to pi by 2, because sine converts to cos and cos converts to sine. If you add, the numerator and denominator gets cancelled, you will get dx. Integration of dx is x between limit 0 to pi by 2 is pi by 2. 2I is equal to pi by 2 means I is equal to pi by 4. Okay, right. So whatever may be the power, the simplification is same. Now let's come to the next property, next problem. This is also the same type problem. Let us convert this first. Now let the given equation can be written as, what is the given equation? Integral pi by 6 to pi by 3 dx divided by 1 plus root of tan x can be written as root of sin x divided by root of cos x. Now this can also be written as integral pi by 6 to pi by 3. Okay, this dx as it is. Take LCM, root of cos x is the LCM, cross multiply, root of cos x into 1 is root of cos x plus root of sin x. So this can also be written as, this is equal to integral pi by 6 to pi by 3, and just transfer this to the numerator. This becomes cos root of cos x divided by root of cos x plus root of sin x into dx. Now let us represent this as I, equation number 1. Now therefore I is equal to pi by 6 to pi by 3 root of cos x divided by root of cos x plus root of sin x dx, equation number 1. Suppose if it is 0 to pi by 2 root of cos x by root of cos x plus root of sin x, means the answer is pi by 2. Since it is pi by 6 to pi by 3, we will get the different answer. Now let us change. Now change x to this pi by 3 plus pi by 6 minus x. Okay. Then this equation becomes, now therefore I is equal to integral, what is the integral? Pi by 6 to pi by 3 root of, so cos of pi by 3 plus pi by 6, pi by 3 plus pi by 6 minus x divided by, in the denominator, root of cos of pi by 3 plus pi by 6 minus x plus root of sin of pi by 3 plus pi by 6 minus x into dx. Now what is pi by 3 plus pi by 6? Pi by 3 plus pi by 6 is nothing but pi by 3 60, pi by 6 30, 60 plus 30, that is pi by 2. So 90 minus theta, sin 90 minus theta is cos theta, cos 90 minus theta is sin theta. So therefore this equation reduces to pi by 6 to pi by 3 root of cos 90 minus theta is sin theta, sin x divided by root of cos 90 minus theta is sin x plus root of sin 90 minus theta is cos x into dx. This is equation number 2. Now let us add 1 and 2. Adding 1 and 2, if you add 1 and 2, I plus I, 2i is equal to integral pi by 6 to pi by 3. What is equation number 1? We have root of cos x by root of cos x plus root of sin x. In the equation number 2 we have, so we can take the LCM, root of sin x plus root of cos x dx gets cancelled. In the numerator we will get root of sin x plus root of cos x. So these two gets cancelled. So 2i is equal to integral pi by 6 to pi by 3 dx. Okay. Now this is equal to integration of dx is x between the limits pi by 6 to pi by 3. Apply the upper limit. So 2i is equal to, first it is pi by 3 minus pi by 6. Simplify, you will get the answer. What is this equal to? Take LCM. What is the LCM here? 6 is the LCM. For 3 and 6 it is LCM is 6. 3 2s gets cancelled. This is 2 pi minus pi. So 2i is equal to pi by 6. Therefore I is equal to pi by 6 to the 12. So the integrated answer is I is equal to pi by 12. This is the required answer. So the answer is pi by 12. Okay, see here. 2i is equal to pi by 6 to pi by 3. Integration of dx is x between limits pi by 3 to pi by 6. So apply the upper limit pi by 3 minus pi by 6. Take LCM. 6 is LCM. So 2 pi minus pi. 2 pi minus pi is pi. 2i is equal to pi by 6. Therefore I is equal to, bring this to the 2 to the denominator. Pi by 6 into 2 is 12. Pi by 12 is the required answer. Hope you followed. Okay. Now same type problem. Instead of trigonometric function, here it is x. This is also very important. Same type problem. Let us consider, let I is equal to 0 to a root of x divided by root of x plus root of a minus x into dx. Let us represent this as equation number 1. Replace x by, as usual, a minus x. So this becomes integral 0 to a root of x can be written as a minus x divided by x is equal to root of a minus x plus a as it is minus, what is x? Minus of this. If you multiply by minus, what you will get? Minus a minus into minus plus, minus a plus x into dx. These two gets cancelled. So what we will have here, therefore I is equal to integral 0 to a root of a minus x divided by root of a minus x plus root of x into dx. Let us represent this as equation number 2. That's it. See, here x it is a minus x, here x it is a minus x is changes to x. That's it. Now adding equation 1 and 2. Adding 1 and 2. If you add 1 and 2, I plus I, that is 2i is equal to integral 0 to a. Let me add these two directly. So what is the LCM in the denominator? We have LCM as x plus root of a minus x plus root of a minus x, root of x plus root of a minus x into dx. In the numerator, what we have? So for the equation x, here for the equation we have a minus x. So gets cancelled. We will get x plus root of a minus x as usual. So these two gets cancelled. 2i is equal to integral 0 to a into dx. So integration of dx is x between limits 0 to a. So if you apply the upper limit, a minus 0 is equal to a. So 2i is equal to a. Therefore, I is equal to a by 2. It's a simplified answer. That's it. So if you add equation 1 and 2, I plus I is 0 to a into first integral plus 0 to a into second integral. So if you take, we'll take this and you can simplify. That's it. So 2i is equal to a, therefore I is equal to a by 2 is the simplified answer. That's it. So this is anyway, this is also a very important type problem. So one property and a problem like this you may expect for your 6 marks. Hope you followed all these type of properties and the problems. These are very important types. You just please practice it. You may get one question from this. So that's all for today's session. Let us meet with the different concept in the next class. Thank you very much.